Hello student, welcome to the class. In this course so far, having studied about angles in detail, the concept of positive and negative angles and the clockwise and counterclockwise rotations and the measures of angle in degrees and in radians and the concept of different quadrants, all of that, we are now in a position ready to discuss the introduce and study the trigonometric functions. Now we will first introduce the functions based on a right triangle, which is how it is you know done, like in the order historically. That is also the historic origin, from the right triangle. But then we will soon go from the right triangle to the unit circle, and then we will see that we can actually apply trigonometry to any angle in any triangle. On the circle you can have every possible type of triangle, not just right triangle. Okay, and not just like angles less than 90 degree, you can also talk about angles more than 90 degree. We will develop ideas for that. Okay, so keep this in mind. We start with triangle, but then generalize the definitions so that we can apply it to any point in the coordinate plane. We do that using unit circle. Okay. Now, the basic definitions. The triangle, a picture is given there, a typical right triangle, and you take one of the acute angles. Say this one here, call it alpha. Okay. Now, with reference to that angle, that is important. Okay. In terms of that angle, the side next to it is adjacent, side opposite to is the opposite side, and there is only one hypotenuse in a right triangle, which is always opposite to the 90 degree. Okay, about the triangle. Based on that, now there are three things here: adjacent side, opposite side, and hypotenuse. You can define 6 ratios. How? You take any side, like you take adjacent, and you can divide that adjacent by either with the opposite or the hypotenuse, right? You get 2 ratios there, and you can repeat that for the other 2 sides respectively in the numerator and the remaining 2 in the denominator. So 2 plus 2 plus 2, 6. Totally 6 ratios are obtained, and each one of them is a trigonometric function. As simple as that. Okay, take a right triangle, divide one side by other side. You can get 6 different ratios, and those are 6 trigonometric functions, and they are all given names. Okay, adjacent divided by hypotenuse is cosine, and in short we write cos. The full name is cosine of alpha, or we just say cos alpha, adjacent over hypotenuse. Similarly, the reciprocal now. Okay, here, from here to here, the relation is reciprocal. Hypotenuse over adjacent will be secant. Okay, in short we write sec alpha. The next pair of reciprocal functions is sine. In short we write sine alpha, and that is, I am just going to write abbreviations here: opposite divided by hypotenuse. Okay, so sine alpha and cos alpha, both of them have hypotenuse in the denominator, something that will be useful as a concept. Okay, the numerator are 2 of the legs. Adjacent is cosine, opposite is sine, and cosecant is the reciprocal of sine, and its abbreviation is CSC. Okay, in some textbooks you will find cosec also. as an abbreviation. But if you want to stick with three-letter abbreviations, as a standard, we use CSC. Okay. Cosec alpha equals reciprocal of sine, right? Hypotenuse divided by opposite side. Okay. Next, in both of them, we have already divided by the hypotenuse. Now we need to think of things that does not involve hypotenuse. Okay. And the first one here, tangent, in short we write tan alpha is opposite divided by adjacent. Okay. And cotangent, in short we write cot alpha is the reciprocal. So adjacent divided by opposite side. Okay. Super important. You need to have this memorized. So I have you might have noticed that I don't insist on memorizing every formula or every like definition. Okay. Some are very important and you cannot not know it. So I'm highlighting it here and I'm going to write it in bold. Memorize. Okay, these 6 definitions. It will go a long way in making your rest of the study of trigonometry smoother. Okay. And now we are immediately going to generalize it. Okay. You could study with that triangle and then you could look at examples and stuff like that. But we are in college level. Okay. So what we will do is let us immediately get into the generalized definition. And then whatever study we have to do on a triangle, we can do that in this generalized definition on a unit circle. Because after all, it's not that we are not going to have the triangle anymore. We will have our triangle, but it will be on the unit circle. Okay. So what is the concept here? Why are we going to a unit circle? Take any point. First of all, remember the concept of unit circle from the previous lesson. Okay. And we're talking about unit circle in the standard position. As I had said, that is always the default. Okay. Not a unit circle anywhere. Unit circle centered at the origin. Okay, so very standard position here, the the center of the circle is 0 0, the origin. The radius of the circle is 1 unit. What more you can ask in terms of regularity? Okay, in that unit circle, some interesting things happen when you start looking at their coordinates. Take any point, say x comma y, on that unit circle. Okay, could be any point. So it's not so ignore the triangle. First there was a point. Okay, and with that point you can create this triangle. How do we get the triangle from the point? You take that point and drop a perpendicular on the um, axis, x-axis. Okay, and then once you drop the perpendicular and you join the radius, you have this triangle, right? And then it has a very beautiful interpretation here, right? In this right triangle, going by the definition of what x and y coordinates are, the adjacent side for this angle, again, if you take that angle to be alpha, that the radius makes with the x-axis, with positive x-axis, okay? That is the standard position of the angle, if you remember, okay? In the standard position, suppose alpha is the angle made by that radius from that point to the origin with the positive x-axis. With reference to or with respect to that angle in this triangle, x coordinate is the adjacent side, y coordinate is the opposite side. hypotenuse is the radius, which is 1 unit. All of this makes the definitions of trigonometric functions for the unit circle, okay, very specific and very simple. What is that? Cos alpha is adjacent over hypotenuse. I'm going to write that for the first one at least. The adjacent side is x coordinate. Hypotenuse is radius whose value is whose length is 1 unit. So you just get the x coordinate. That means x coordinate of the point on the unit circle is the value of cos alpha. Similarly, y coordinate, okay, because sine is opposite divided by hypotenuse, so it's y coordinate. Cos alpha is x coordinate, sine alpha is y coordinate. Basic understanding, and I'm going to write that here. So this point x comma y can be written as cos alpha comma sine alpha, where alpha is the angle from the point made by the radius from the point to the origin, okay, on the unit circle. Then finally, tan alpha is opposite by adjacent, which will be y over x. That, by the way, let me jump ahead, we'll be talking about these ratios later, but you can see that this becomes sine alpha over cos alpha. Not just on the unit circle, that is also generally true. Okay? Important formula, by the way. What next? That's now beautiful. Okay. It is going to help us get the basic graph of the sine and cos, even tangent functions, just by that unit circle definition. Okay. How? We will evaluate these trigonometric functions. First, the simple ones at the quadrantal angles, okay, which is the 0 degree, the 90 degree, 180 and 270 degree, or along the axis basically. Look at the x-axis and y-axis, both positive and negative. X-axis is here, y-axis is there. And by the way, I didn't talk about that. You have this unit circle. So looks like in my picture, things are a little misaligned. That point 1, 0 is supposed to be there. Okay. So this is the point negative 1, 0. And over here you have 0, 1. Over you have 0, negative 1. Right. The coordinates of the 4 points on the unit circle. Positive x, 1, 0. Negative x, negative 1, 0. On y, 0, 1. Positive, 0, negative 1, negative. Okay. Based on that, let us evaluate the values of, let's say, the cosine function at the 4 angles here. Okay. What will that be? On the unit circle, cosine is basically the x coordinate by definition. So if you now look at the graph, where is my x coordinate? I'm going to highlight for the first one. Okay. X coordinate when the angle is 0. So I'm so sorry. X coordinate is 1 when the angle is 0. The first one is x coordinate. Okay. So at 0 degree, the x coordinate is 1. Hence, cosine of 0 is 1. Okay. I'll do one more, then you can complete the rest. At 90 degrees, the x coordinate is 0. Hence, cosine of 90 degree is 0. Please go ahead and complete the table. Pause the video, do that and check with me now. cos 180 is -1, cos 270 is back to 0, and cos 360 is again 1. 360 degree is the same as 0 degree. Alright. And now again, you do it yourself first. Apply the fact that sine of an angle is the y coordinate of the point on the unit circle, and use the y coordinates here. I'm going to remove these highlights, and I'm now going to focus on the y coordinate. Y coordinate at 0 is 0, y coordinate at 90 degree is 1, and so on. Okay, use that and write the values of sine. And now check with me. Sine 0 is 0, sine 90 is 1, sine 180 is again 0 on the x-axis, y coordinate is 0. 270, you are now at the 0, -1, and back to 360, which is 0. Okay, that is sine and cosine, and actually that is enough to generate the rest of the table. Okay, you don't have to necessarily go by you can even the tan I said earlier, you can do sine divided by cos. Okay, but for now let us do the definition way. Y over x is tan. So what you do is y coordinate is the second one here, the sine, and x coordinate is the cosine, right? Y over x. So you divide and write 0 divided by 1, 0. 1 divided by 0 will be, I'll just write u and d here, the shortcut. The u and d will stand for undefined, which is basically going to plus infinity and minus infinity, being asymptotic. We have that understanding in our mind. While writing in the table, we will write undefined. Okay, 1 divided by 0, no? And then again, next 0 divided by -1, 0, -1 divided by 0, undefined, and 0 divided by 1, 0. Okay, now looks like the graph of tangent will not be super clear at this point. We will need now more information. Okay, but the graph of sine and cosine, we will have some idea just from these values. We will come to that later. Okay, let us complete the rest of the table. How will you do it? Secant is reciprocal of cos. Okay, 1 over x. So reciprocal of 1 is 1, reciprocal of 0 is undefined, reciprocal of -1 is -1, reciprocal of 0 is undefined, reciprocal of 1 is 1. Okay, and I'm sometimes simply using the vertical line, sometimes I'm writing the proper one. I try to make sure that it is not confusing. Okay, but sometimes I might be saying it, I'll say 1, so be attentive. Like I wrote 1 over x here. Okay, just with the vertical line. Okay, cosec is reciprocal of sine, 1 over y. So reciprocal of 0 is undefined, 1, 0. No, what did I say? Reciprocal of 0 is undefined, 1 is 1. Reciprocal of 0 is again undefined. Reciprocal of -1 is -1. And reciprocal of 0 is again undefined. Finally, for cot, you can do the reciprocal of tan, which is x over y. So where there is 0, its reciprocal is undefined. Where it is undefined, now that's the understanding. Okay, undefined is plus infinity or minus infinity. So when you take the reciprocal, 1 over that, it becomes 0. Okay, undefined, 0. Okay, so these are the trigonometric ratios on the quadrantal angles. Okay, I was saying that we will be graphing these functions. The table gives you already some idea about sine and cosine, but for the rest of them, it's a little unclear. Not little, it's unclear if you just look at those values. Okay, it's like 0 and then undefined directly. So how does it, like, first of all, is it going to plus infinity or minus infinity, right? That will be those gaps, in between will be filled. Now if you look at angles between 0 and 90, sorry. Okay, and though, and in that, not every random angle, first we will start with some special right triangles with some special angles. Okay, the first of them is 30 degree, 60 degree, 90 degree. At least for this one, I will not only give you the coordinates but also show you how it is obtained. It's interesting geometry work. Okay, but for the other ones, I would expect you to do it on your own. Okay, it's similar, you can replicate the process. So this is 30 degree. Okay, and I'm interested in knowing what are the coordinates here, right? At 0 degree, here we know it is 1 0. At 90 degree, we know it is 0 1. What is it in between when the angle is 30 degree? Okay, for that, this is an exercise in trigonometry. Okay, not trigonometry, sorry, geometry. I mean, I'm going to take this another line. Okay, I need to make it like that. Okay, I'll complete it into a triangle, equal type of triangle on the other side. So you can see that, that also in magnitude, that is also be 30 degrees. So what I have here is an equilateral triangle, right? This is 1 unit, that is 1 unit, 60 degree total. Okay, if you measure this 30 plus 30, 60, and those radius are equal. So isosceles triangle, that makes these base angles equal. And one of them is 60 degrees, so the remaining two also, if they are equal, have to be 60 and 60, right? All three angles are 60 degrees. It is an equilateral triangle. Now what happens in an equilateral triangle? All sides are equal. So 1 1, and this side here, now I'm going to mark it in a different way. That one, that length also is 1, right? Okay, this length is now 1 unit here. How much is half of it at the midpoint? Half up, half down, right? The total is 1, which means this height here from here to here is half. Very interesting, right? So what was that height? That height was the y coordinate, half. Okay, and let's write that here. The y value is half. The radius is 1. And how do you get the x value? Pythagoras theorem. Okay, what does Pythagoras theorem say? X square plus y square will be 1 square. Right? Just to help you understand clearly, I'm going to be sketching an angle in the other quadrant so you'll see it clearly. If this point is x comma y, it could be any point, right? Then this length here is x and this length is y. The radius of the unit circle is 1. So in that right triangle, you can see here x square plus y square will be equal to 1 square. Okay. So if you apply that there, you get x square plus y is half. Half square will be 1/4 equals 1. If you solve it now, x square will be 1 minus 1/4, which is 3/4. And that gives you x equals plus minus under root 3 divided by 2. You take the square root of both numerator and denominator. Under root 3 divided by under root 4, which is 2. And plus minus because you are taking the square root. But then you discard the negative value because we are in the first quadrant. Both have to be positive, right? Hence, you are left with the positive under root, which is under root 3 over 2. So those are the coordinates corresponding to this angle 30 degree in the first quadrant. Okay. Just keep that in mind for now. We will go to the next. For 45 degree, similarly, okay, x-axis, y-axis, unit circle, and 45 degree would be here. Okay, and do this by yourself and verify the values you get would be 1 over root 2, or it is often written as root 2 over 2 by rationalizing the denominator. Okay, and earlier we saw 30 degree. There's a counterpart to it, the 60 degree. Okay, so I just write that here, and the 60 degree diagram is like this. Need to be a circle. Okay, and let's say that is 60 degree. Then the coordinates of that point would be the opposite, 1 over 2 root 3 over 2 compared to 30 degree. Okay, the x and y will interchange, as you can imagine. Okay, so these coordinates are the ones that again you should have a handy, either you should memorize, I would recommend, okay, but I'm not insisting. Otherwise you should have this in your note cards, this diagram handy with the values of the trigonometric functions, with the values of those coordinates, okay, at different angles. Not just in the first quadrant, we will do this now in the other quadrants as well, using the next concept called reference angles and triangles. Okay, but all of that starts at the base level with these three angles between 0 and 90 degree in the first quadrant. 30 degree, 45 degree, and 60 degree. Look at the coordinates once again. And we did the 30 degree previously here. Root 3 over 2, 1 over 2. Okay. Moving on. Reference angles and triangles. Now, suppose you want to, okay, the situation, I'll use one of the previous diagrams. The situation is, or let me draw a new diagram. Why to make that messy? Here. Okay. You are sometimes, interested in angles in other quadrants. Like, what if you want to find the value here? Say this angle is 150 degree, right? Now we know the concept of the trigonometric functions in the unit circle, which has now been generalized. By the way, I didn't talk about that earlier. I talked about it, but again I should have connected it when we defined the functions. We have generalized the idea of trigonometric functions, right? Now it is no longer the just the opposite by hypotenuse and so on in the right triangle. In the unit circle, we made it into x coordinate and y coordinate definition, right? So in that sense, I will be able to define the trigonometric function for this point also, for this angle also, for 150 degree also. And according to that, what are the coordinates? The x coordinate is cos 150 degree here. The y coordinate is sin 150 degree by definition. Okay. Um, not by definition, by adapting the definition, I would say. We said that the coordinate will be cos alpha, sin alpha. We saw that in the first quadrant. But what if we generalize that now and say that for any angle alpha, now this would be the way cos alpha and sin alpha is defined. Okay. The cos alpha and sin alpha are basically the x coordinate and y coordinate on the entire circle. So that means at this 150 degree, from origin counterclockwise, the positive angle, that points coordinates are cos 150, sin 150. So the question is, how do I evaluate that? And it is in that context that we need the reference angles and triangles. Okay. What is it? Given any non-quadrantal angle, non-quadrantal, so not 0 degree or 90 degree or 180 or 270. Okay. So something in between. Non-quadrantal angle in the standard position. Okay. Oh, sorry. I should say non-standard position. Oh, no, my bad. Standard position. What do I mean is um, not in the first quadrant, could be in any quadrant. That's what I meant. I said non-standard. No, it is the standard, but could be in any quadrant. Okay. And what do I mean by standard position is you are not talking about this angle. You are not talking about the clockwise angle, or you are not talking about this angle, like from y-axis. We are talking about angle from the positive x-axis, the standard position. Okay. For such a angle, you can define a reference angle which will be used to evaluate the value of the trigonometric functions at those angles at 150 degree. Okay. What is it? Its reference angle is the positive what you call acute angle. So positive angle less than 90 degree. Okay, just like in the first quadrant, in a positive acute angle formed by its terminal side. Okay, now in this case, the black radius with the arrow that I have marked there is the terminal side of that angle, right? For every angle in the standard position, the initial side is the positive x-axis. The terminal side here is that one. formed by its terminal side with the x-axis. Now you have to understand here something very important. Okay, we are not saying made with the positive x-axis. Made the acute angle, so less than 90 degree, and made with x-axis, could be positive, could be negative. And in this case, if you see that acute angle, something less than 90 degree would be this. And zooming in and showing the pink arc that I drew just now to indicate the angle. I will do it again. This angle. That would be the reference angle. Okay. Again, look at that and listen to the definition. For every angle in the standard position, the reference angle is the angle made by the terminal side with x-axis, either positive or negative. The x-axis and that the side of that angle. Okay. So if that is 150 degree, obviously this will be 30 degree, right? That will be our reference angle. Okay. Now here's the thing. It's 30 degree. Now you might say that, am I from where to where am I measuring? I'm measuring clockwise or counterclockwise. We lose that meaning for a second because we just take the positive value by definition. We define it to be the positive angle, but it could be formed with either positive or negative x-axis depending on where your um, uh, depending on where the angle is. Okay, all right. So this was an example. I will ask you to find your on your own, and then I will write the answer here. If your angle is, let's say, 240 degrees, find the reference angle. Pause the video, find it, and check with me. And I hope you found this. 240 degree. I'm doing dotted for making it less cluttered now. Okay, that's 240 degree, 180 plus 60, right? So that tells you this 60 degree here is your reference angle. Okay. So again, to highlight and super emphasize, we don't talk about this angle. That's not the reference angle. The green one is not the reference angle. Okay, the 60 degree is there with x-axis. Okay, that is a reference angle. What is a reference triangle? We already have it there, right? You could complete that into a triangle. So what will you do? Not complete that, sorry. It's not there. We have to construct it now. But we have the angle to construct the triangle. Okay. Reference triangle are special right triangles with the vertex of the reference angle, uh, the vertex of the reference angle at the origin. Okay. And a leg forming a right triangle with the x-axis. What we mean is, okay, I think I might have to draw a different diagram. I'll do that on the side here. That's too many things already there. Okay. Let's say you have this coordinate system and you are talking about, now I'll draw only the angle. Okay. Let's say we're at this angle here. Which would be, if you go clockwise, that will be 315 degree. Counterclockwise. Okay. And we have discussed just now the reference angle for this would be the 45 degree here made with the x-axis. And now we're talking about the reference triangle. and I will make all of that in pink or purple, whatever this color is. That triangle is your reference triangle. Okay. The are the right triangles with the vertex of the reference angle at the origin and the the leg forming a right triangle with the x-axis. So this leg here, this the parallel to y-axis, that leg is forming a right triangle with x-axis, right? So that would be the reference triangle for that angle. Okay, so we can put angles in parentheses here. So this concept of reference angles and reference triangles will be used to evaluate the trigonometric functions at any angle. Okay, here is the process. Evaluate the trig function at the corresponding reference angle. See, that is the beauty, that is the utility of the reference angle. Reference angle is between 0 and 90 degree, right? And we, before this, for the standard angles, at least we have done that activity where we know the x coordinates and y coordinates. So we can find the trigonometric function, right? Using the x and y coordinates and the definition. So evaluate the trig function at the corresponding reference angle. Not in the angle, as it is not at 315 degree, not at 315 degree, but at 45 degree, okay, which we know how to do. And then step 2, determine the sign based on the quadrant. Now, that could be positive or negative, right? Trigonometric functions will have negative values if you are not in the first quadrant. In the first quadrant, everything is positive, but if you go to second, third, fourth, one or other trigonometric ratio can be negative. So that sign is determined by looking at the quadrant. Examples. Okay. 150 degree. Let's go back to this diagram that I drew here. For 150 degree, the reference angle is 30 degree. Right? So what I'm going to do, sine 150 degree is basically sine 30 degree. The question is it plus sine 30 degree or minus sine 30 degree? To answer that, you have to look at the quadrant. A small diagram is enough to do that. Okay, let me erase this steps here. 150 degree is here, second quadrant. Okay, in the second quadrant, the y values are positive, right? Remember, sine is y coordinates. Okay, and that is positive. So you leave it at plus sine 30 degree. And what is the value of sine 30 degree? That is the y coordinate at 30 degree. For that, you have to go back to the previous page at the bottom. At 30 degree, the y coordinate is half. You can see in the top right here, okay, half. So going back here, at 30 degree, the y coordinate is half. Second quadrant, sine is still positive. So sine 150 degree is sine 30 degree is half. Okay, follow. I'm going slowly. You also go slowly. Make sure you digest it properly. Next, cos 150 degree. Reference angle is 30 degrees, so that will be cos 30 degree. Question is plus or minus. We are in the second quadrant. In the second quadrant, x coordinate is negative, right? Y coordinate is positive. That's the second quadrant. And cosine theta, by definition, is the x coordinate in the unit circle definition. See, everything we have been talking about from the beginning of the video is required here. Okay, things will done. So you cannot skip, you cannot miss, you cannot afford to not understand previous concepts. Cosine is x coordinate. So second quadrant it is negative, and that gives you negative root 3 over. Okay. And finally, tan 150 degree is tan 30 degree. Now, what was the value of tan 30 degree? We have not done that actually previously. So let me use that opportunity here. Now, we have to yet to decide the sign. Okay, so let me leave the blank here. Question mark for the sign, but let us look at the value of tan 30 degree. Okay, to do that, we will use the y coordinate over x coordinate definition. Tan 30 degree, I'm writing below that in, or maybe you can write here. Okay, it's y coordinate over x coordinate. At 30 degree, the y coordinate was 1 over 2, the x coordinate was root 3 over 2, right? And if you simplify that now, you get 1 over root 3. The 2 and 2 cancel, you get 1 over root 3, which is further simplified as root 3 over 3 by rationalizing the denominator. Okay. All that is tan 30 degree. In the second quadrant, tan, by the way, this definition tells you whether it will be positive or negative. It is y over x, right? Y is positive, x is negative. So the ratio will be negative. Hence, these question marks will be negative signs. So negative tan 30 degree, which is negative y over, okay, not negative y over x. It's the definition is y over x, but the value will be negative ultimately. So the answer would be negative root 3 over 3. I'm going to write that here so not making a mistake. Okay. Sign from the quadrant, value from the reference angle. Okay. Let us do some practice problems. Find the exact values of the trig functions where alpha is in the standard position and whose terminal side contains this. Okay. So in this problem, we are adapting the concept that we did with the unit circle, except that this is not a unit circle because the radius is not going to be 1, x square plus y square will be under root 5 here actually. And let us do this. Okay. Negative 1, negative 2. So 1, negative 1 here, let's say, and negative 2, hopefully somewhere there. So the point you are talking about is here, negative 1, negative 2. Negative 1, negative 2 here, negative 1 here. Say that will be 1 here, 2 here, negative 2 here, and so on, right? You can mark the triangle like that. 1 here, 2 here. And we need to find the values of all these ratios. And to do that, let us first complete the triangle. Here is our triangle. And what is the angle alpha? In the standard position, whose terminal side is that. So in the standard position means we're talking about this angle here. This is the angle alpha. Okay. X-axis here, y-axis here. Sine, and now we have to find all of this, sine alpha and all of that. And what did we say will be the trick? The trick will be to use the reference angle. So reference triangle and reference angle. The reference triangle now, I'm going to show it in red color, is going to be here, dotted one. That is the reference triangle. In that reference triangle, Oh, actually, um, let me go back. I should have marked the negative one little carefully. I'm going to do that again. Let's say negative one is here. Okay. The reason is this triangle then meets at that point, right? At negative one. Okay. So in terms of absolute lengths of the triangle sides, this side is 2 units, that side is 1 unit. It doesn't look like that because I did not do a good job at sketching it. 1 and 2. Okay. Negative 1, negative 2. So lengths are 1 and 2, which means the radius is going to be under root 1 square plus 2 square. Right? The length at that is under root 5. So this side is under root 5. So what will be sine alpha in this triangle? That is the reference angle for alpha. So the opposite is 2, radius is root 5. By the way, I'll write that here, okay? R is always positive because radius is just the length of the hypotenuse here. We don't talk about the quadrant here. Just keep that in mind. So I'm going to circle it here, this piece of information. Okay, the radius is always taken to be positive in all your calculations. So sine alpha is y coordinate by radius. Opposite will be y coordinate. Hypotenuse will be radius, by the way. In the unit circle, it is y, just y. In a general circle, it will be y divided by r. That would be the hypotenuse, right? In this case, the y coordinate is negative 2. So negative 2 over root 5, that's sine alpha. Leave it at that. I'm just going to show with an arrow up. Or if you rationalize it by multiplying by root 5 up and down, it will be negative 2 root 5 over 5. Okay. Similarly, cos alpha is x coordinate over radius. The x coordinate is negative 1. Radius is under root 5. If you rationalize it, that is negative root 5 over 5. Okay. Go ahead and write the values of the other ratios and then check with me. Tan alpha would be y over x, negative 2 over negative 1, which will be 2. So you are noticing something here. The value of tan alpha is positive, and this is in the third quadrant. Later we will be needing this kind of knowledge. Okay, tangent is positive in the first quadrant and third quadrant because it is the ratio of y and x, right? If both are positive or both are negative, the ratio will be positive. Once you have sine, cos, tan, we are done basically because the others are reciprocals. Cosec alpha is reciprocal of sine alpha. So negative root 5 over 2. This value is useful here, okay, because the denominator will be already rationalized. And similarly, sec alpha is reciprocal of cos alpha. So negative root 5. And cot alpha is reciprocal of tan alpha. So that's 1 over 2. Okay. Evaluate or find the exact value without using a calculator and then use the one to verify. So this is a good exercise for you. Okay. Draw the unit circle, look at the coordinates, and try to determine these values. And then take your calculator, punch in. I will talk about that also in a second, how to do on a calculator, and then verify. So let me first show you without using a calculator. Okay. For example, cos negative pi over 2. So what you do? Take the unit circle. In the unit circle, look at the angle we are talking about. Negative pi over 2 is going clockwise. So we are talking about the point 0, negative 1. Okay. And cos is the x coordinate. Right? X coordinate is 0. There is nothing to think there. By the way, which also was note. Or I'll write that as a note here. Okay. Cos pi over 2 was also 0, right? That would be here 0, 1 in the first between first and second quadrants, 90 degree. So cos minus pi over 2 and cos pi over 2 both are zeros. Okay. What is cosec pi over 4? Okay, I was saying in the calculator. In the calculator, I just wanted to say make sure you are in the radian mode. Number one. Number two, use the pi button for pi. Don't type 3.14, it's not going to help. You are going to get some decimal values, Use the pi button for pi and make sure the calculator is in the radian mode. Okay. Cosec negative pi over 4. So again, let us talk about the unit circle. But this time let me just draw the angle. Okay. Because there's too many things here. That doesn't look like 45 degree. Here, let's say. That would be negative pi over 4 in the clockwise sense, right? So what would be the coordinates here? That will come from the reference triangle. Now remember, for pi over 4 in the first quadrant, the coordinates are under root 2 over 2 and under root 2 over 2, 45 degree, which is pi over 4. But now we are in the fourth quadrant. In the fourth quadrant, x is positive, y is negative. So negative sign in front of the y coordinate there, negative under root over 2. Alright, that's the point. Now what is cosec? It's the reciprocal of sine, which is 1 over y coordinate. And the y coordinate is negative root 2 over 2. So 1 over negative root 2 over 2, which will be negative root 2 when you simplify. Okay. Tan 2 pi over 3. Now this will take you back to another concept as well, which is the dividing the circle into various segments, right? Various components, like with 30 degree, 45 degree, while discussing the area of the sector, and that we have talked about that concept earlier. We are going to use that here. What was the idea? With pi over 3 or with 60 degree, your division was something like this. First 60 degree here, second 60 degree here, the third 60 degree would be the negative x-axis. Okay. So x here, y here. That 60 degree is pi over 3. Pi over 3, which means this one is your 2 pi over 3. 3 pi over 3 will be, of course, the negative x-axis or angle pi. So that's the point now we are talking about. Tan 2 pi over 3. And for 2 pi over 3, if that is 2 pi over 3, I'm going to write here, okay? The reference angle is pi over 3. What remains is in a pi over 3. If your measurement from here, that is 2 pi over 3, the reference angle is pi over 3. For pi over 3, the coordinates that you can write here. For pi over 3, the coordinates are 1 over 2, root 3 over 2, right? Pi over 3 is the angle, 1 over 2, root 3 over 2 are coordinates of the points, okay? Don't confuse. I wrote the angle there because it's cluttered to write inside the circle here. But you have to understand, let me see if I can do. This is the point, angle pi over 3, this part, okay? And if maybe then I can remove this and bring that. I just all of that will come here, okay? 1 over 2, root 3 over 2 for pi over 3. Tan 2 pi over 3 in the negative side. So I'm again going to erase the angle here. I'm going to write the coordinates. Coordinates would be the same 1 over 2 root 3 over 2, but now you are in the second quadrant, right? That is how, that is the beauty of the, that is the usefulness of the reference triangle and reference angle concept, okay? Now you are in the second quadrant where x coordinate is negative. So that will be negative 1 over 2 root 3 over, right? And what will be tan? Tan will be y over x, which will be root 3 over 2 over negative 1 over 2. That is negative root 3. That is how we can compute trigonometric functions at all these different angles. Okay. Go ahead and draw the unit circles and evaluate for the next two problems. I'm just going to write the values there and pause the video and do that so you can check with me. Okay. For sec negative 3 pi over 4. Pi over 4, 2 pi over 4 will be 270 degree. Negative side 3 pi over 4 will bring you to third quadrant. Negative 3 pi over 4 will be in the third quadrant where the coordinates are negative root 2 over 2, negative root 2 over 2 because your reference angle is pi over 4, but you are in the third quadrant, and cosec is reciprocal of sine, so that will be negative root 2. Mental work. Okay. You do the physical work. Sorry. Next. Sine 5 pi over 6. Now you have to think in terms of the pi over 6 fragments, which is 30 degree. 5 of them, so 150 degree. You are in the second quadrant. The coordinates of 30 degree, I mean that I'm not saying equal to, you understand it. The coordinates of 30 degree are root 3 over 2, 1 over 2. So for 150 degree, which is in the second quadrant, it will be negative root 3 over 2 and 1 over. So sine is now y coordinate, which is 1 over 2, 1, and cosine, cos is x coordinate. Okay. Now that is the substituting, finding the values and substituting. The next work I'm doing now is simplifying radicals. Okay, and especially getting the answer to have a final answer to have a rational denominator. A review of your basic work that we do in school, but it's worth paying attention to if you are not already good at it. Okay, try and simplify as much as you can and then check with me. 1 over 2 over, now we'll take the common denominator, right? 2 over 2 minus root 3 over 2. That 1 I rewrite as 2 over 2, so I can have common denominator. I will continue that here. 1 over 2 and 2 minus root 3 over 2, right? I took common denominator. Now that cancels because it's a over b over c over d. You know that denominator and denominator will cancel. So what am I left with? 1 up, 2 minus root 3 down. Okay, but you will be generally asked to write your final answer with rational denominator. So what you do? College algebra stuff. Okay, remember? Sorry, I said high school earlier. No, not trying to be condescending. High school and college algebra, wherever, okay, whenever you mastered it. That is 2 plus root 3 over 2 plus root 3 and 2 plus root 3 over now a square minus b square. 2 square minus under root 3 squared, and that will be 2 plus root 3 over 4 minus 3, 1. Okay, so I'm skipping that now. You understand it. Denominator will be 1. So 2 plus root 3 is your final answer. Okay, very good practice problem. We're doing some more. Okay, use a calculator, round to 4 decimal places. Now, first thing, make sure that it's in degree mode. Cos 344.1 degree. I'm going to show you with the calculator that I have on my iPad. Do a similar thing on your Texas Instruments calculator. Okay, all clear. And cosine function is here, but where's the degree? And yeah, this will be radian mode. If I click, you can see on the top left. Oh, I cannot zoom in. There is rad written there, so that's in the radian mode. I press the degree button here. Now I guess that's in the degree mode. Okay, we will see. You can verify with some simple one. Sine 0 degree, but 0 doesn't help. 0 would be 0 in anything. Sorry. Let's do 90 degree. Sine 90 degree should be 1. Okay, so we are in the correct mode. That is another way to check, right, in your calculator if you are confused, where it is showing. So what are we doing here? 344.1 cosine, sorry, already the parenthesis has already opened. 344.1 in degrees, it is in degree mode already, and turns out to be 0.96174. 0.96174. I'm going to remember that. 0.96174. Okay. I said all digits, but we don't need more than that to round to 4 decimals. Okay. Why? Because that would be 0.9617. That's less than 5, right? So you just drop it. Did I expect this to be the value? Answer would be yes. And why is that? That's because 344 degrees like back to almost 0 degree. Okay, 360 degrees, 0 degree back, right? Um, so this would be close to that, and I know cosine 0 is 1, you know. So this value would be something close to 1, and it will be positive, by the way. In the fourth quadrant, x coordinate is positive, so the cosine is expected to be positive. Okay. Next, cosec 49 degree and 13 minutes. First of all, you will have to convert that to degrees, right? So 49 plus 13 divided by 60 degrees. That's what we are evaluating here. Okay, so that is the expression I am evaluating on the calculator. But A typical calculator, 49 plus 13. Okay, I'm going to remember that. A typical calculator is not going to have cosec, not cosine. No, cosec. Okay, right? That was the thing. So it's not going to have cosec button. What do? You use the sine. 1 divided by sine. Okay. And what was sine? 49 plus 13 divided by 60. That's the angle. Okay. In parenthesis, that gives you, converts it to degree, and 1 divided by sine of that gives you cosec. 1.320681. Okay. 1.320681 and more digits. Round to 4 decimal, 1.3207. Okay, because the next digit was 8. So you round up to 7. All right. Next question. Find the exact value of sine 2 theta if theta is pi over 4. Okay. If theta is pi over 4, this question could be used for some other applications also. In this case, it's easy. Okay, 2 theta will be pi over 2. So sine, I'm going to show in two different ways. Okay. So sine 2 theta will be sine pi over 2, and that will be 1. Okay. Okay, I said that I'll show you another method, but that will require the use of the double angle formula, which comes much later in the course. We'll discuss that then. Let me not get ahead. Okay. This problem turned out to be simpler. Okay. Here's an activity for you. This is a very good activity. Okay. And if you are watching my video, doing a course with me on trigonometry, I will probably be giving this as an optional extra credit activity, which if you are doing, you can go ahead and do the activity and um, remind me if I have not already created an assignment for you to, uh, get credit for that extra credit. Or I'll just ask you to send me in the message or email, and I will be doing that. Okay. But otherwise, if you are just watching this on YouTube and learning trigonometry, this activity will be really useful in helping you remember the values of the angles or the trigonometric functions at different angles. Okay. And it will be a beautiful butterfly that you can, make it. Maybe if you are, um, a college, and if you are going to be celebrating some math event, you can do take this as a project and show it as a presentation. This is a trig butterfly, and to make it beautiful, you can do your, you can use your sketching skills and do the coloring part. The math part is, first of all, not this size, make it a big one. Okay. And at these various angles. All right. In your butterfly, what you do is use different colors, maybe like, for 30-degree, and for uh, that, and so on. Okay. Use different colors. And in that, you be writing here. So make the circle also bigger. Okay. Outer circle bigger. So between this, you can write the values of the coordinates, right? for 30 degree. Again, to remind, that was root 3 over 2 and 1 over 2. And then you can do that for using the concept of reference angles and reference triangles. Good practice for you, actually, opportunity to practice. There should also be y-axis here, by the way. Okay, I don't know why it is missing. The y-axis is there. And with the idea of the reference angle and reference triangles, on the y-axis, maybe you can draw the head of the butterfly. I don't know. Do it. Okay, you make the artistic work, and write the values in all the quadrants. Practice in the process. Okay, I will leave it at that. I'll see you in the next lesson, in the next video. Thank you for watching.